So robotics are not just helping us here on Earth. Autonomous vehicles are enabling us to explore the solar system itself. But traversing other planets isn't so easy. To take a look at how planetary rovers might better estimate driving energy based on vision, I'm joined by Dr. Shoya Higa. Dr. Higa, welcome. Thank you for joining us today.
Yeah, thank you. Yeah, it's really appreciated.
It's a great pleasure. So why is estimating driving time actually important?
So because the future Mars rover could be solar powered and also expected the long distance driving, we need to energy optimal path planning. So as a first step for the energy optimal path planning, we need to predict how much energy consumes before rover travels. So that's the main part of our research.
What's wrong with the existing way of doing it?
So existing way would be using some sensor value, then estimate what the current energy or simply measure the energies from the rover sensors. But there is no way to predict since the rover is not there, so how we know the energy consumption before rover there.
And how much do you think that new way of doing things is actually going to help exploration of Mars?
So I believe that's a very good question, and that's really helpful. If the rover travels, the hilly area, and the rover may want to select the sun-facing area to choose the energy charging, and if the current way using, the rover probably select the distance minimum path.
Gotcha.
Yeah.
Well, you've brought it with you, so maybe you could show us a little bit of your innovation.
Okay. So here is our algorithm field test movie. So first, the rover set the RGB map, the XYZ map, and this combined, and we set the path here, and each path contains RGB and XYZ patch. Then this is the result from our network, and the black line shows the ground truth, the current measurement, and this blue and the orange shaded area is the actual prediction side. So you can see this is the climbing sandy slope area, and we made the VeeGer-EnergyNet, and VeeGer-EnergyNet is pretty much better than the EnergyNet. Something like this. Yeah.
I mean, so what's the next step for your research?
So I would say we'll expand this algorithm to the path planning side so that the rover can plan where he or she should go.
Right.
So, yeah.
And what sort of timescales are we looking at then for the kind of wider exploration of Mars using this technology?
Not quite close, but future Mars rover, probably after the Mars 2020 rover, there is a Mars sample return rover. We are aiming to putting this together by then, but we'll see. Okay. Maybe a little bit later, but after then, probably this technology could go to the Mars or Luna or somewhere. Yeah.
Well, thank you very much indeed for sharing it with us today.
Yeah, thank you so much.
Fascinating. Thank you very much.
Thank you.